So let's see what this problem is asking us for. It wants us to express the vector 1, 3, 2 as the sum of two vectors, v and w. So in other words, we want to write u as the sum of two vectors v and w, and one of them we want it to be parallel to the vector 1, negative 2, 1, and the other we want it to be orthogonal to 1, negative 2, 1. To make things easy for ourselves, let's call this vector r, vector 1, negative 2, 1. And let's understand what we need to do. So the idea is pretty simple. If you have the vector u, and let's say that this is r, my choice of these line segments is completely arbitrary. They don't reflect the actual vectors. But regardless, the projection of u onto r is going to be the parallel vector. So this is going to be v. And the difference u minus v is going to be the perpendicular vector. So this is going to be w. So w is almost by definition u minus v. Okay, that's the idea. So we should begin by finding the projection. So v is going to be the projection onto the vector r of the vector u. And what is the formula for the projection? It's u dot r over r dot r, and we scale r by this number. So in other words, we're supposed to compute the dot product on the numerator, the dot product on the denominator, find this number, and then scale r by that number. You have to be careful here not to be tempted to do a cancellation of r with r. These are dot products. It's not usual multiplication. So this is going to be 1, 3, 2 dot 1, negative 2, 1 over 1, negative 2, 1 dot 1, negative 2, 1. Sorry, it's dot product with itself. And you need to scale the vector 1, negative 2, 1 by the quotient of these two numbers. Okay, let's do the computation. So what is the dot product of 1, 3, 2 with 1, negative 2, 1? So 1 times 1 is 1. 3 times negative 2 is negative 6. 1 minus 6 is negative 5. And 2 times 1 is 2. Negative 5 plus 2 is negative 3. You can pause the video and do the operation yourselves, but that's what you're going to find. And what's the dot product of 1, negative 2, 1 by itself? It's going to be 1 square plus negative 2 square plus 1 square. That's 6. And you want to scale the vector 1, negative 2, 1 by this number. And what is this going to give you? Negative 1/2, 1, negative 2, 1, which actually gives you negative 1/2 negative 2 times negative 1/2 is simply 1, and negative 1/2. Okay, so this vector is indeed parallel to the vector r because it's a scalar multiple of it. Two non-zero vectors are parallel if and only if one is a scalar multiple of the other. So we found v, and now w is going to be simply u minus v, meaning it's going to be 1, 3, 2 minus negative 1/2, 1, negative 1/2. How much is this? 1 minus minus 1/2 is 1/2, is 1 plus 1/2, sorry. So that's 3/2. 3 minus 1, that's 2. And 2 minus minus 1/2, so 2 plus 1/2, so that is going to be 5/2. Okay. And actually, if you wanted to double check and take the dot product of this with R, you would see that it's 0. And so we have, finally, our answer is that the vector 1, 3, 2 is negative 1/2, 1, negative 1/2, plus 3/2, 2, and 5/2. And this vector is parallel to 1, negative 2, 1, and this vector is orthogonal to 1, negative 2, 1. So what we reviewed in this problem is precisely the notions of the dot product, the projection of a vector onto another vector, and the interesting property according to which if you subtract the projection of a vector onto another vector from your initial vector, you will find one which is perpendicular to the vector onto which you're projecting. And that's all. Thanks for watching.